Modern game engines such as Unity are designed to create virtual environments for use in video games. They offer a variety of powerful tools that allow level designers and engineers to build virtually any level they desire. During the design process, developers have to put themselves into the perspective of players in order to create the expected gameplay experiences. However, especially in virtual reality games, the stark difference between the viewpoints of developer and player can be a challenge and potentially result in a lowered level fidelity. Therefore, we wanted to investigate the feasibility of transferring select level design tasks from the flat-screen Unity editor to VR itself. To achieve this goal, we devised 4 separate methods for the manipulation of virtual objects through the use of handheld motion track controllers and a VR HMD. The first method is called fishing reel. Level designers can select objects in the scene with their left hand, tethering the former to the latter, allowing for translational and rotational manipulation. The right hand can then be used to control the distance of the object to the left hand, allowing for more accurate placement at varying extensions. The second method, referred to as hand grab, is the most natural interaction technique. When a developer places both hands on an object in the virtual world and grabs it, they can carry it around with them like they would any real-world object, modifying position, rotation, and even size in the process. This allows for great precision and placement of objects close to the user, but doesn't allow for manipulation of objects outside the designer's real-life arm length. The third method is the force technique, in which the developer can select objects using their left hand, locking them in until released by the press of the B button. A selected object's translation can be influenced using waving from the right hand, similar in appearance to Jedi hand movements. The final method is called world in miniature technique and doesn't allow designers to influence the world directly at all. Instead, a miniaturized copy of the world is projected onto the left arm, where objects can be manipulated using a one-handed pinch using the right hand. To evaluate the effects of our 4 methods, a user study was conducted. Users' performance in the VR editor was directly observed, and time spent on tasks as well as precision of placement was taken into account. A modified version of the system usability scale (SUS) was used to evaluate overall usability of our system. Subjectively, participants chose the world in miniature as the best method and the fishing reel technique as the worst. While experienced users gave the system a better usability score, it still only reached an average of 68%, indicating that the system needs improvements to be a good alternative to traditional level design tools. In conclusion, it can be stated that users can quickly learn to use a basic level editor in VR to their advantage, especially if some guidance is provided. Finally, we would like to thank every contributor to this project as well as all survey participants.